Gerald Gayo Congo.
Host ane akatorerwa mic host.
Uchipiwa assignment usina kana kumboatenda chizumi chunogona kutopenga ka chii ichochi.
Verenga vano
Chamanotsa chakawanda unoshaya kana pekutangira chama unotoda kana wiki rese kuti uerenge wozonyora assignment.
Iroga kuindbvema kwese zimene vanga vachidhembwa nato.
Gentlemen, ndosaka ndambosagesta 4 weeks kapaipa ndichiziva kuti nyaya yekuresearch anaka tangomhanyira 3 weeks.
Elections kukaita hondo after my elections tinge tichiita sei manje mahwanaya tounaita mumwe mwedzi tiri kuhondo.
Besides Mr. Mugambia, chikoro munochiziva inini 4 weeks hapatorina. Zvinhu izvi zvinotoda kana 2 months chaizvo, but 4 weeks unenge watomira semurume. Reading while list uchigadzira zvako pakaipawo man.
Semester ya 3 months handi mukuziva. 1.5 for first cluster, 1.5 for the second cluster. Saka mukada kutoti 4 weeks ka 4 weeks teta kutonyora first zama re-first cluster.
All right, fine. Let's proceed. Right. Do we have questions on what we have done? Do we have questions? Questions?
Sir, you were requested to send the questions that you have given to us, those in red, number 1 up to 30.
I've sent the document to Makosa so that you can then share again. Makosa, are you there?
Yeah, I'll say I'm there.
Did you see the document?
Yeah, let me check. I was listening to what you were saying.
Oh, all right, fine. I want to share certain documents on median mode in standard deviation there. Right, I want to share a document there. Right. Right. Can you see something there?
Not yet.
Okay. We are going to discuss the measures of central tendons. That consists of mean, median, mode, standard deviation, this and that. So I'm not going to take much time on that one, but I just want to give you a brief or a snapshot of what you are expected there. Right. It's a very simple thing, but you have got to understand. Can you see something yet?
Yes, it's there now, Doc.
Yes.
Yes, doctor.
All right, fine. Okay, let's see there. Right, descriptive statistics. That's the document which is showing there. Right. Right. So there's what we call measures of central tendons. It consists of mean, median, mode, percentile, and quartiles. Can you see that? Can you see something on the
Yes.
screen?
Yes, Doc.
So you need to be able to calculate a mean. You should be able to calculate a median. You should be able to calculate a mode. You should be able to calculate percentile. You should be able to calculate a quantile. Right. Now let's look at this. The arithmetic mean. The arithmetic mean is commonly called the mean. It is the average of a group of numbers. It is a concept of applicable for interval and ratio data. It is not applicable for nominal or ordinal data. The mean is computed by summing all the values in the data set and dividing the sum by the number of values in the data set. All right. Thus, its value is affected by each value in the data set, including the extreme values. So what you need to do there now is you have got to arrange your data. That's the first thing. Arrange your data. If you are given numbers that are, there's 1, then there's 10, there's 15, there's 0, arrange, and 0 is a number. Are we together there?
Yes, doctor, we are together.
As a summary statistics of central tendencies in data produced by business and economic processes, when used in these settings, it is important to make the distinction between the population mean, which is mu. Okay, you see that sign? This one is mu. Can you see that? This sign depicted by like a U is called mu. And the sample mean is X bar. All right? The population mean is based on all of the values within the population. The sample mean only uses some of the values within a population. Right. For example, suppose a company has 5 departments with the 24, 13, 19, 26, and 11 workers in each department. The population mean numbers of workers in each department is 18. Right? Is what? Is 18.6. Right. So what you do is when you are given a data set like this, we've got 24, 13, 19, 26. Right. In most cases, no matter you're calculating mean, no matter you're calculating medium, you have got to arrange the data first. Right? So what you do, there's a summation of 24 plus 18 plus 19 plus 26 plus 11. It will give you 19. It will give you 93. That's the summation, isn't it? Right. So for your mu is the summation of x, these numbers, divided by n. If you count there's 1, 2, 3, 4, and 5. So that's divided by 5. The data set consists of 5 numbers, so it's divided by 5. So you get your mean there. That's the average. Right. So computing is sample mean. Right. The calculation of a sample mean uses the same algorithm as for a population mean and will produce the same answer if computed on the same data. However, a separate sample is necessary for the population mean and for the sample mean. Right. Given the following set of numbers, 57, 86, 42, 38, 90, and 66, the sample mean is 63.167, right? So you compute this and you divide it by 6. 1, 2, 3, 4, 5, 6. The 6 numbers there, right? So that's how it is, right? Then the mean is the most commonly used measure of central tendons because of its mathematical properties and because it uses all the data points in the data set. However, the mean is affected by extremely large or extremely small numbers. Note that for the sample mean example, if the largest number is 90, is replaced by the number 1000, the mean becomes 214.883 opposed to 63.167. Why? If the smallest number 38 is replaced by the number 5, the mean becomes 57.66 is opposed to 63.167. Extreme values can significantly distort the mean. That's the concept there. Right. So whenever you're asked to calculate either mean, median, what the first thing before you forget, arrange the numbers or arrange your data set. Right? Now let's go to the median. If you forget to arrange your data set, if you're asked to calculate the median, which is the middle number, you will not be able to do that because your numbers are scattered and you will not be able to actually figure out which number is in the middle. So in this case, the median is the middle value in an ordered array of numbers. The median applies for ordinal interval and ratio data, right? So let's look at this. The first step is arrange the observation in an ordered array. That's the first. Second, for an array with an odd number of items, the median is the middle number, right? If your data set is arranged in order, the median is the middle number. So the third step is for an array with an even number of items, the median is the average of the two middle numbers. Locating the median location is in an ordered array is found by n plus 1 divided by 2. Right? N is the value of those numbers. Okay, that's the number. If they are 5, so it will be 5 plus 1 divided by 2. Right. Let's look at this example. Let X be an ordered array such that X is the following values: 3, 4, 5, 7, 8, up to 22 like this, right? Let X be an ordered array. So what it means is that if you check these numbers, they are actually arranged from the lowest to the highest, which means the highest is 22 there. So this means that this is ordered array. The data is arranged. If you are to count these numbers there, you would find out that there are 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Right? That's N. Right. So there are 17 values in the ordered array, as I've demonstrated there. So position of the median is with our formula that we've just been saying just now, N, which is the ordered array number, which is 17 plus 1 divided by 2. So it's 17 plus 1, get 18 plus 2, that's what? 19. So the position is on the 90th position. So if you count the 1, 2, 3, 4, 5, 6, 7, 8, 9. Gives us what? The 15th position. So the median is the 15 is 15 there. That's the median. Are we together there?
Yes, Doc.
Are we understanding? Fine.
Yes, Doc, we are together.
So that's how it is there. So on that one, I think I'm done on that one. Median of with an even number, right? If X be an ordered array such that X assumes the following values, right? Like as you can see there are 16 values in the ordered array. If you count these numbers, there are 16 there. So if you go to our position, if you go to our formula, the position of median is n plus 1 divided by 2. So if you say 16 plus 1, that's 17 divided by 2, that's 8.5 position. The median is a value between the 8th and the 9th, okay? Position, observation in the ordered array. The median is 14 plus 0.5, which is this, right? That's 15 minus 14, okay? Which is got 14.5, or simply you just say 14 plus 15 divided by 2, you get 14.5. Okay? There is also another formula I have highlighted on the answer sheet, what do you call it, on the tutorial answer sheet. You also see another formula that I've used. In case you don't want to use this one, you can still use the other formula that I've shown there. Then mode. Let's look at the mode. The mode is the value that occurs most frequently in an array of data. The mode applies to levels of data measurement: nominal, ordinal, interval, and ratio data, right? Then an mode now describes data sets with a single mode. Bimodal describes data sets that have two modes. Multimodal describe data sets that contain more than two modes. Right? So we are saying mode is the number that appears frequently in an ordered array, right? So organizing the data into an ordered array helps to locate the mode. Okay? The mode, the number that appears most. Right. So if you are to check the arrangement of the number represents an ordered array, 44 is the number, is the value that occurs most frequently. Okay, that's occurs 5 times. So if you have to check this 44 there, it's the one which is appearing most frequently. Okay, so we are saying mode is the number that appears more frequently. So if you have to check there's 44, there's 44, there's 44, there's 44, there's 44, there's 44. It's appearing most frequently. So it becomes our mode. Right. Then we look at the percentile. The percentiles, there's what we call our data will be the maximum will be 800. It's divided into 4 parts, which means that's 100. So percentiles are measures of central tendency that divides a group of data into 100 parts. Right? I think this is quite simple. You go and read this and you follow the formulas that I've given you there, and then it's simplest. And you go and read this. So at the end, you must be able to answer the questions that are on that I've given you on the tutorial questions. All the formulas are shown there. Where you have got a problem, let me know. Okay? These are measures of central tendency. It's very rare to write an examination without understanding this. It always comes through, right? So you go inside this. Are we together there? Hello?
Yes, Doc, we are together.
Yes.
Doc. Following, Doc.
All right, fair enough. Right, so for today, I want you to go and concentrate on measures of central tendons. All right? Measures of what? Of central tendons and the, what do you call it? You go and concentrate on measures of central tendons plus the, let me check on that one. And hypothesis testing. Those two. Go and concentrate more on measures of central tendons and hypothesis testing. Those two. So that when you come back, we know whether you've understood them or not. Right. I want you to take you back on hypothesis testing. Let's just check there. Hypothesis testing. Right. I want to share a certain document there. Okay, let me see which one to share. Right, I'm stopping to share that document. Let me share another document there. Right. Can you see something there?
Not yet.
Doc.
Not yet. All right. Let's see. Right. Hypothesis testing.
Yeah, now shown.
Now shown. Right. Right. On hypothesis testing,
Not yet.
you can see something.
It is showing.
Right. I have given you the, what do you call it? The questions on hypothesis testing, and part of it is following under your assignment. Right. So you need to determine the type of test that you want to carry out if you are to do hypothesis testing, right? You need to determine whether it's a two-tailed test or a one-tailed test. Okay, just someone, sorry. Hello? Right. Hello?
Hello?
Right. So you need to find out which type of test do you want to carry out. And then is it a two-tailed test or it's not a two-tailed test? And then when you are doing that, you need to draw, and then you need to ascertain the acceptance region and the rejection region on your diagram, right? Are we together there?
Yes, Doc.
You need to ascertain
Yes.
those two things. What it means is that you actually draw, right? We had problems with students who were doing accounting last time because they knew they can calculate the figure fast. So they never wanted to follow the steps, like the steps that I've given you, that you follow those steps, like test, state the now and the alternative hypothesis, state the level of test or significance, and then state the rejection criteria. Okay, when you say state the level of the test, you say we are testing at, you actually write a statement, okay? You actually write a statement. We are testing at 5% level of significance, okay? Then you go to number 2, state the rejection criteria. That's when you draw, okay? You draw now, and then you ascertain the acceptance region and the rejection region. So you put your significance level there now. Okay, this is our significance level. This is our Z-score. You mention it there, and then you move on now. So you should label if they are if it's a two-tailed test, then you put the values there. Are we together then? Are we together?
Yes, Doc. We are following.
Right. Then you need then to know which one is your mu, which one is your mean, which one is your X bar, and which one is what is your standard deviation, depending on what you are given. Are we together then? Then there is what we call type 1 error and type 2 error. You have got to understand it. Right. So you go and read there, because you can get a statement which can ask you in an examination situation, is this a type 1 error or a type 2 error? And you must be in a position to understand this. Right. But for now, what is very important now is to understand how to calculate, okay, one-tailed, two-tailed, to calculate the critical values. There it is. Okay. A 10% minus 1. If you are given the values, you just insert the values. But if you're not given the values, we have got to calculate those values. Or in an examination situation, you are also given the, what do you call it? You are given the tables. So you can ascertain now from those tables. Right. So you go and read this and be in a position to calculate. Where you have a problem, let me know. Right. For now, the work remains yours. Go and calculate. Go and read. Where you have a problem, don't hesitate to consult me. Call me anytime. It's tea time. Right. So that's how it is. So go and concentrate on those two, and then also at the same time doing your assignments. Right. So I've concentrated much on this because it's also touching more on your assignment. Particular assignment 2, assignment 3, where you need to calculate. Okay. Right. Any questions before we call it a day? Any questions before we call it a day? Hello? Hello?
Hello, Doc. So far, so good. I don't know others.
Right. So
So far so good.
okay, fair enough. So
far so good.
okay, fair enough. So I want,
Probably.
and then all the materials I've given you, including the answers for those questions, particularly the ones that need calculations. I've sent you the whole study pack, including the answers. So what's left is for you to go and see where you don't understand and where you need assistance, so that we can assist each other before. I'm sure we might need to do what you call it, face to face just after the elections. I'm sure we'll be given a green light from the registry when we are going to start but I'm sure it could be after elections. So what you need to do is go and work out where you feel you've got a problem. You can give me a call, or you can just give me a WhatsApp.